What is Stateflow and MATLAB Simulink used for? Imagine you're working on a project that needs to switch between different modes or respond to specific events automatically. How do you make sure your system behaves correctly in each situation? That's where Stateflow in MATLAB Simulink comes into play. It's a powerful tool designed to help engineers model complex decision-making processes visually. Stateflow allows you to create diagrams that show how a system transitions from one state to another based on certain conditions or events. Think of it like a flowchart, but specifically for controlling how systems behave. It's especially useful when your system has different modes, like turning on or off, switching between different operating states, or reacting to faults. In electrical engineering, control systems often need to respond to real-world events quickly and accurately. For example, in automotive electronics, Stateflow can model how an anti-lock braking system switches between braking and releasing modes. In power systems, it can simulate how a circuit breaker responds to overloads or faults. It helps engineers design systems that are reliable and safe. One of the main uses of Stateflow is designing finite state machines. These are models where a system can only be in one state at a time, like a traffic light being green, yellow, or red. Stateflow makes it easy to define these states and set rules for how the system moves from one to another. This helps in controlling devices like automatic transmissions or battery management systems. It also helps with event-driven logic, where actions happen based on specific triggers. For example, if a sensor detects a fault, the system can switch to a safe mode automatically. Stateflow makes it simple to set up these triggers and responses visually, which improves understanding and debugging. Another key benefit is that it combines discrete decision-making with continuous system models. So, you can simulate how a physical system behaves while also considering the logical decisions it makes. This is especially useful in embedded control systems where both types of behavior are important. Stateflow also makes fault detection easier. You can model how your system should respond to different faults and test these scenarios before deploying hardware. This reduces errors and saves time during development. Plus, the visual nature of Stateflow diagrams makes complex logic easier to read and maintain. In practical terms, electrical engineers use Stateflow to design systems like engine controllers, electro-hydraulic controls, or safety systems. It integrates seamlessly with Simulink, allowing you to test and verify your control strategies in a virtual environment. This way, you can catch issues early and ensure your system will perform as expected in real life. Overall, Stateflow in MATLAB Simulink is a key tool for creating clear, reliable models of systems that depend on states and events. It helps engineers develop smarter, safer, and more efficient control systems by providing a visual way to design and test complex logic before hardware implementation.